Hello student, in previous class I discussed about the second quantum number, that is your azimuthal quantum number. Azimuthal quantum number is denoted by small l. There is a relationship between azimuthal quantum number and the principal quantum number. This is the relation. L varies from 0 to n minus 1. The relation is given here. L is equal to 0, 1, 2, 3 dotted n minus 1. Next, I have also completed the other significance of azimuthal quantum number. Azimuthal quantum number helps to determine the maximum number of electron in a subcell. This is the formula 2 into 2l plus 1. Next, azimuthal quantum number also saw about the shape of subcell. Here, the shape of subcell S is your spherically symmetrical. P is the dumbbell shape. D is the double dumbbell shape, F is the triple dumbbell cell. In this class, I will clearly explain the shape of different orbitals. Azimuthal quantum number also helps to determine the orbital angular momentum of an electron. This is the formula. L root over of L into L plus 1 into h by 2 pi. Azimuthal quantum number also helps to calculate the number of orbital in a subcell. The formula is your 2L plus 1. Azimutha, here S means SAR, P means principal, D means diffuse, F means fundamental. Next, I have also covered the magnetic quantum number. Magnetic quantum number is denoted by small m or ml. It helps to explain about the orientation of the orbital. Magnetic quantum number have an also relationship between azimuthal quantum number. This is the relation m equal to 0 plus or minus 1 plus or minus 2 plus or minus 3 dot plus or minus l. Next, I have also covered the last quantum number, that is your spin quantum number. Spin quantum number is denoted by S or ms. Spin quantum number have two value. One is your S is equal to plus half, another is your S is equal to minus half. S is equal to plus half is used to denote the clockwise direction spinning of an electron. S is equal to minus half is used to denote the anticlockwise direction spinning of an electron. Next, I have also completed few problems regarding about the azimuthal quantum number. These are some problems here I have already discussed. In this class, I will explain about a new concept, that is your shape of different subcell, shape of cell and subcell, and we also think about the shape of different orbitals. Actually, what happens when we think about an atom? In the atom, at the center, nucleus is present. Suppose this is your nucleus, then the cells are present in the spherical like, but modern concepts are that the cells are spherical in nature, but old concepts are that cells are circular. So these are the different cells present here. So here I can say that the electron revolve around the nucleus in a circular path, which is called cell. The outermost occupied cell of an atom, which determine its chemical property, is called the valency cell. Actually, if you think about the valency cell, let me explain what is valency cell. Suppose you think about the nitrogen atom. Nitrogen atom having atomic number 7. After In the upcoming class, you will clearly explain about the electronic configuration of an atom or ions in terms of orbitals, or you can think about the subcell. But in the metric class or ninth class, you know clearly about the electronic configuration of an atom in by using cell. You know that for K cell the electron is your 2. Then there are for nitrogen there are 7 electrons. 2 electron goes to the K cell. The remain 5 electron is present for the L cell. Look at that. Here K cell is the inner cell, L cell is the outer cell. This outer cell is called valency cell, and the electron present in the valency cell determine the chemical property of this atom. Remember, the electron present in the K cell do not determine the chemical property of the atom. Only the outermost electron that is present in the outermost cell, that is your valency cell, determine the chemical property. And this cell is popularly known as a valency cell. So for nitrogen, the L cell is said to be valency cell, and K cell is said to be the inner cell, that is your said to be core cell. So here I can say that the outermost occupied cell of an atom which determine its chemical property is called the valency cell. Except for the valency electron, or the other electron are called core electron, and these cells are said to be inner cell. Yeah, let me explain other point. What is valency cell? Suppose an atom is given, that is your chlorine. Atomic number of chlorine is your 17. If you want to distribute the electron in the cell, then what will happen? K cell carry 2 electron, L cell carry the maximum capacity of electron in L cell is your 8. So give 8. Now calculate, that is your totally 10 electron, but here 17 electron is present. So there are 7 electron remain. So the 7 electron present in the M cell, that is your having the M cell having your 7 electron. Look at that. The outermost cell in which electron is present, that is your M cell. So M cell is said to be the valency cell, and other cell are said to be the inner cell, and these electron are said to be core electron, and the electron present in the valency cell is your said to be valency electron. Similarly, you can think about any other atom. Suppose I want to take another example. Suppose take lithium. Lithium having atomic number is 3. The electron configuration is 2 1. 2 for K cell, 1 for L cell. Here the last electron, the valence electron, the last electron goes to the L cell, and the L cell is the valency cell, and here the valence electron is number of valence electron is 1. And K cell is the inner cell, and the 2 electron present in the K cell are considered as the core electron. Remember, the last electron present in a particular cell, that cell is called valency cell. Remember, maybe it a L cell, maybe it a M cell, maybe it a N cell, like that. Remember, the last electron present in which cell, that cell is said to be valency cell, and other are said to be inner cell, and the electron present in the inner cell are said to be core electron. Similarly, you can think about the other atoms by drawing the electronic configuration in terms of the cell. Next point is the each cell consists of one or more subcell, and each subcell consists of one or more orbital. Already I discussed in the quantum number. Let me explain here again. Here K cell having the subcell, that is your S, and it have also the same name, that is your as a S orbital. Yeah, for L cell there are two subcell. One is your S, another is your P. S subcell having the orbital is your own, that is your S. P having three orbital, that is your Px, Py, Pz. Remember this list of orbital and their subcell and cell. Next, if I will think about the M cell having three subcell S, P, D, S having one orbital. This is the one orbital. P having three orbital. Already I discussed in the L cell. Px, Py, Pz. But the new term is your Z subcell. Z subcell having five orbital. Look at that. These are dxy, dyz, dzx, dx square minus y square, dz square. Let me think about the N cell. N cell having four subcell. S having the S orbital. P having three orbital, already discussed. D having five orbital, already discussed in the M cell. F having seven orbitals. Let me clear here. The orbitals are Fx, fxq, fyq, fzq, fxyz, fx z square minus y square, fy x square minus z square, fz y square minus x square. These are the seven orbitals belongs to the f subcell. Let me explain the first orbital, that is your s orbital. What is the shape of s orbital? Remember already discussed in the quantum number. The shape of s orbital is your spherically symmetrical. Spherically symmetrical means, look at that. Suppose if you think about these are the shape of s orbital. Look at that, all the shape are spherical. What is the meaning of symmetrical? Symmetrical means they are having the equal part. Suppose if you think about this subject, this is an square. If you cut like here, then this part is equivalent to this part. So here we can cut the square into spherically, sorry, that is your symmetrically. Symmetrically means when you cut anything, then if you will have two part, then the two part are equal. Suppose think about the 1s. This is your 1s, this is the nucleus. If I will cut here, then this part is equal to this part. Suppose someone cut like here, then the upper part is equal to the bottom part. Suppose this is the nucleus, suppose someone cut like this, then this part is equal to this part. You can cut the sphere in any direction, then you will get the symmetrical portions. So here the shape of s orbital is your given, that is your spherically symmetrical. About the nucleus, and it is unidirectional. It have no many direction. That is your said to be unidirection. These are the some example. One is having the spherical symmetrical. This is the structure. If you think about the 2s, 2s belongs to the, that is your L cell, 1s belongs to your K cell, and the 2s having the shape like this. Look at that. This is your nucleus. Let me explain. This is your nucleus. This is your 1s. Okay. The next, there is a node. There is a gap between 1s and 2s. This is the gap. Here there is no probability of finding electron. Here you cannot see any electron in this region. Node is an region. Node may be a plane. Node may be a point. Node may be a three-dimensional sphere where no electron you cannot find. Here the presence of electron is zero. You cannot find the electron here. So this is the node. After that, 2s. This is the 2s. This is the 2s. Okay. This is the 2s. Clear? Here you can find here you can able to find the electron present in the 2s. In this position, you will find the electron present in the 1s. In between the 1s and 2s, there is a space in which electron cannot find, that is said to be node. In between the two orbital, one node is present. This is one node. Let me explain about the 3s orbital. Look at that. This is the nucleus. This is your what? This is your said to be 1s. Here only 1s electron is present. Next, this is the node. Here no electron will found. Here you cannot find no electron. Next, this space. This is for 2s. Look at the picture. This is for 2s. Here 2s electron will found. Next, this is the node again. There is a separation between 2s and 3s. Here no electron will found. This is also a node. That is your said to be node. Next, this is your this region. This region is said to be the 3s. Here 3s electron will find. Look at that. If you think about the 4s, 4s having structure like this. I will try this. This is your nucleus. Look at that. This is your nucleus. I want to draw a big. This is your nucleus. Here what happens? This is 1s. This is your 1s. Here a nodal is present. Circular nodal. Here the probability of finding electron is 0. You cannot find any electron. This is your 1s. Next what happens? This is your 2s. In this region 2s electron will found. This is for 2s. Next you will think about there is a separation region in which the electron will not found. Okay. This is your 2s. I will write in small size. That is your 2s. You can write your 2s. Next, this is the region where you cannot able to find any electron. This is also a node. Let me explain clearly. Then here is this is your 3s. This is your 3s. Here 3s electron will found. The probability of 3s electron in this region is maximum. Then a separation space. Here no electron will found. This is also another node. Here we can able to find any electron. This is your one node. Next, this is your 4s. This is your said to be 4s. Clear? Here we will able to find the 4s electron. Clear? Look at that. If you think about the 1s orbital, the number of node is your what? 0. There is no node. There is no gap. There is no space. There is no point where you unable to find any electron. Here there is no node. Means here there is no place. There is no space where the probability of electron is 0. Next thing about the 2s. Here this is the node. One node is present. Here I can say that one node. Think about the 3s. 3s having two node. This is one node. This is another node. That is your two node. Think about the 4s. 4s have three node. One, two, three. Three node. If you think about the 5s. If you think about the 5s, then what will have? There are four node. Clear? Look at that. For 1s, 0 node. For 2s, 1 node. For if you think about 3s, 2 node. For 4s, 3 node. For 5s, 4 node. Here if you think about the general representation, then you can write here ns. If n is equal to 1, it represents 1s. If n is equal to 2, it represents 2s. If n is equal to 3, that represents 3s. If n is equal to 4, that represents 4s. If n is equal to 5, that is represent 5s. Okay. If for ns orbital, suppose a question will ask how many number of node will find for ns orbital. Then what is your answer? Look at that. For 1s, 0 node. That means there is a less 1 minus 1, that is your 0. For 2s, here you can write 2 minus 1. For 3s, the number of node is your 3, sorry. That is your, you can write 3 minus 1, that is your 2. For 4s, you can write 4 minus 1, that is your 3. For 5s, you can write 5 minus 1, that is your 4. That means see, if you think about this, then you can write n minus 1 node. N minus 1 node. Clear? I think all are getting well. Next, look at the point. What is nodes? One more question will ask. What is node? A node is a point, or maybe a region, maybe a surface where the electron probability is zero. Zero. What do you mean by the meaning of electron probability? Electron probability means finding of electron. How much possibility to find an electron? That is said to be electron probability. In node, you cannot find any. Here already I have proved. In general, if let me explain again here. Again, I want to repeat. Again, I want to. Again, I want to repeat. For ns orbital, n minus one node. Suppose someone asks a question: how many nodes present in the 7s orbital? You use direct this formula. That is your 7 minus 1. That is your 6 node. Suppose someone saw that how many nodes present in the 9s orbital. Then you can directly say that 9 minus 1, that is your 8 node. Clear? This is the general concept. Ns orbital has n minus 1 node, already verified by giving example. This is all about the shape of s orbital. A single 1 mark question will always ask, what is the shape of s orbital? That is your answer is your spherical symmetrical. Next, move to the shape of p orbital. There are three p orbital. Already we know that px, py, pz. Three p orbitals have an equal energy. Px having suppose x energy, then py almost x energy, pz also x energy. That means all the three orbitals having the same energy and same shape. Look at that. There are three px orbital are given here. All are having same shape and they are having same energy. Then tell me what is the difference? This is your said to be px. I will clearly explain why this is said to be px. This is your py. This is your pz. What is the difference here? If you will think about the shape, all are having equal shape. If you will think about the energy, all are having equal energy. What is the difference? The difference is only the alignment, the placement of the orientation of the orbitals. If you think about the px orbital, if you think about the px orbital, look at that here. This there are two lobes. Let me say an orbital having generally two lobes. Generally two lobes. One is your upper lobe, another is your lower lobe, bottom lobe. Look at that. Here two lobe is present. This is the one lobe. Here this is the another lobe. If you think about these two lobe summation, then it is said to be px orbital, p orbital. This is the said to be nodal point. That is said to be nodal point. Here you cannot find any electron. Here you cannot find an particularly you cannot find about the px electron. The electron present in the p orbital you cannot find here. This is said to be nodal point. In S, I have already seen about the nodal point. Here the nodal region. Here the nodal space is look like a circular. But if you think about here, the nodal that is your node is your a nodal is a point that is your said to be nodal point. The probability of electron is 0. The two lobes are present in the x-axis. Look at that. This is the x-axis. This is your y-axis. This is your z-axis. There are three axes present. This is your 3D. If the two lobes are present in the x-axis, that is your said to be px orbital. If the two lobes present in the y-axis, that is your said to be py orbital. If the two lobes are present in the z orbital, z-axis, that is said to be pz orbital. Look at that py orbital. Look at that. This lobe is present in the y-axis. This lobe is present also in the y-axis. This is said to be nodal point. Next thing about the pz, your one lobe. This is the another lobe. Both the two lobes are present in the z-axis. So this is said to be pz orbital. Let me explain. The three p orbital px, pyz are the three p orbital px, py, and pz are oriented along the three axes: x-axis, y-axis, z-axis. Px related to x-axis, py related to z-axis. Py related to the y-axis, pz related to the z-axis. So here we can say that the three p orbital px, py, and pz are oriented along the three axes x-axis, y-axis, and z-axis, which are mutually perpendicular to each other. Which are mutually perpendicular to each other. Let me explain how the orbitals are present here. I want to take in three pens, then I will clearly explain you. Think that there are three axes present. I want to say that look at this. This is your one pencil. This is your one pencil. Look at that. This is your one pen. This is also another pen. If you want to see the three axes, then how can you able to see this? Look at that. This is the three axis. Try to understand. There are three axes here I have taken. Suppose this is your x-axis. Suppose this is your x-axis. I want to say that whether all are okay. Suppose this is your suppose this is your x-axis. This is your y-axis and this is your z-axis. There are three axes present here. One is your x-axis, another is y-axis, another is your z-axis. Look at that. If you think about this, see that I want to show you clearly. Okay. This angle is your what? 90 degree. This angle is also 90 degree. And if you think about this angle is also 90 degree. Again, I want to say that suppose this is your x-axis, this is your y-axis, this is your z-axis. If you think about the x-axis and y-axis, there is an angle of 90. Here also 90, here also 90. I am trying to show in the diagram. Actually, if you think about the angle between x-axis and y-axis, this is your 90. Think about the z-axis and x-axis. This is also 90. Next, think about the y-axis and z-axis. This is also 90. Clear? They are mutually perpendicular to each other. Mutually perpendicular to each other means all are having 90 degree. The lobes here also you think about 90 degree. This is your 90 degree. This is your 90 degree. All are 90 degree. X-axis and y-axis, y-axis, z-axis, and z-axis and x-axis. So here we can say that they are mutually perpendicular to each other. The lobes of px, py, and pz are directed along the three axes: x-axis, y-axis, z-axis. Already I discussed. There is an important question, one more question. What is the shape of p orbital? The shape of p orbital is a dumbbell shape or flattened sphere. Try to understand what is the meaning of dumbbell shape. Do you know what is a dumbbell? This is the one type of dumbbell. Clear, the shape is look like this. Dumbbell. Clear? Here I have given the shape like this. This is one dumbbell upper part. This is the next part. Tightly bind here by a string. Here again I want to show that. What is the meaning of flattened sphere? Flattened sphere means take a ball. Suppose this is an football. Bind here by a small rope, or you can use a thread. Take a ball and bind the thread in between the ball. What will happen? And tightly pull the thread. Then what will happen? This portion squeeze. This portion squeeze. This look like smallly, slowly. What happens? Look like this. Clear? Again, when you will pull, that is pull tightly. Then what will happen? A time will come. The ball will like this. That means a time will come. This look like this. Okay. So it is said to be flattened sphere. Let me explain the nodal plane. Here, nodal plane is present. Suppose I want to say that. I think all are looking this. I will try. Suppose this is in paper. There are three axes present here. Let me explain how I will explain. Look at this. Here, suppose this is your x-axis, this is your y-axis, this is your z-axis. Think about the px. A lobe is present here. A lobe is present here. Second lobe is present here. One lobe is this, another lobe is this. Then what will happen? A plane is present here. I want to start like this. I want to try to explain. Take an rough paper. This is your paper. Let me explain. This is your, let me explain. This is your x-axis, this is your y-axis, and this is your said to be z-axis. Let me explain. This is your z-axis. One lobe is present here. One lobe is present here. Let me, I will try to explain. Okay. Let me explain. This is your x-axis. Here one lobe is present. Here another lobe is present. But think about the x-axis. This is the x-axis. Here x-axis is present. This is the z-axis. A plane is passing. This plane is here. Look like this. This is your plane. Clear? I want to explain in the diagram. Look at this diagram. This is your suitable diagram. Look at that. This is your py orbital. This is your x-axis. This is your y-axis. This is your z-axis. This is the first lobe, one lobe. This is the upper lobe. This is the lower lobe. These two lobes are present in the y-axis. Clear? Next thing about the x-axis and z-axis, they make a plane. This is the plane. This is the plane which is passing through the center of the three axis. This is the center. This is your nodal point. But if you think about this plane is here, there is no probability of finding electron. This plane is said to be nodal plane. That is your said to be one nodal plane. This is your said to be particularly xz nodal plane because the plane is situated in the x-axis and z-axis. For py, remember for py orbital, xz nodal plane is present. Xz nodal plane is present. For px, you can think about the yz nodal plane. For pz, you can think about the xz nodal plane. Clear? So here you can say that the plane separating two lobes. This is the plane which separates this lobe and the lower lobe. Having zero electron density, that means the probability of finding electron is zero. Probability of finding electron equal to zero is known as what? Nodal plane. One mark question will ask always, what is nodal plane? Nodal plane is the plane which separate the two lobes of each orbital and having zero electron density. That is called nodal plane. Remember an important point. Every p orbital have two lobes. Every p orbital have two lobes. Look at that py orbital. This is the first lobe, upper lobe. This is the present the below lobe. Suppose here the probability of finding electron is your x. In this law, also the probability of finding electron is your also x. Both having same probability of finding electron. Similarly, if you think about the px orbital, here also x, here also x, having same probability of finding load. So think about the pz, here x, here also x. Both lobe have the same probability of finding electron. Let me show about the 3p orbital, that is your px, py, pz in a three-dimensional axis. Then what will be the structure? What it will look like? Look at that. This is your x-axis. This is your y-axis. This is your said to be z-axis. Here we can say that this is the px orbital. This is your said to be px orbital. Then what is the py orbital? This is the py orbital. This is the py orbital. And this is your pz orbital. If you will take three orbital in a picture, then the picture look like this. So here we can say that representation of 3p orbital. This is the representation of 3p orbitals. Let's move to the shape of d orbital. What is the shape of d orbital? There are 5 d orbitals. One is your, I want to write 5d orbital, dxy, dyz, dzx, dx square minus y square, dz square. I will give a small trick how you will remember this. Take a circle. This is the circle. Remember this. Suppose this is your x, this is your y, this is your z. Look at that. Think about x to y. This the arrow mark is look like this. After x y will come, after y z will come, after z x will come. So write down like this. Think about first d orbital dxy. Look at that d. You can write d and xy. Think about next orbital. The next orbital must be y and z. That means here we can write yz. Next orbital is your what? Zx. That is your dzx. Don't say that dxz. Don't say that dyz, dyx, dzy. Don't write like this. Write like this in the circular representation. Dxy, yz, dyz, dzx. Next, another is your what? Dx square minus y square. Another is your dz square. 5d orbitals are having equal energy. All 5 orbitals are having equal energy like the 3p orbitals. The 3 here there are two, we can divide the 5d orbital into two parts. First part is your dxy, dyz, dzx. They are look like same type. And the other two part is your dx square minus y square dz square. They are two parts. So here I can say that three of these orbital dxy, dyj, dzx project in between the coordinate axis x-axis xy, yz, dzx respectively. The other two orbital dx square minus y square dz square lie along the coordinate axis. Let me explain. What is the meaning? Think about any orbital that is your dxy, dyz, dzx. Look at that. This is the stock three axis: x-axis, y-axis, z-axis. What will happen? Suppose think about the dxy. This is your x-axis, this is your y-axis, this is your z-axis. So what will be the structure of dxy? One lobe is present here. Look at that. This is this lobe is present in between the axis. In between the axis. That is your one is your x-axis. This is your y-axis. Clear? Here a lobe is present in this position. Don't think that the lobe are present, that is your along the coordinate axis. They are present in between the axis. Yeah, yeah. This is your x-axis, this is your y. You can think about this. Here we will find like this. Clear? We will find like this. One lobe is present here. Another lobe is present here. Look at this. This is the second lobe. Next lobe is present here. Next lobe is my hand. Clear? That means four lobes are present in between the axis and they are present in the x and y plane. Clear? Similarly, think about the yz. Similarly, think about the zx plane. Look at that. Here, this is your dxy. There are four lobes. Remember the first three orbital dxy, dyz, dzx having four lobes. Four lobes. This is your dxy, this is your dyz, this is your dxz. Clear? Look at that. One, two, three, four. Four lobes are present in each case. Clear? Dxy, dyz, dzx. That is your thing three. These three orbital first. Later I will explain the other three, other two. If you think about the dxy, look at that. Your four lobes are present and the four lobes are found in between the x-axis and y-axis. This is your y-axis, this is your x-axis. Here a lobe is present, yes or no? Here also a lobe is present in between x-axis and y-axis. Similarly, think about here, one lobe is present, here another lobe is present. These four lobes are present in the plane of xy. Similarly, think about the dyz plane, dyz d orbital. The four lobes are present in the dyz orbital. Let me explain this diagram. This is the py orbital. Look at that. Here, what will happen? This is your what xz plane. Here one lobe. Here one lobe. Here one lobe. Here also one lobe. Clear? I want to try to draw again. This is your one axis. This is your x axis. This is your y axis. This is your z axis. Sorry. X-axis, Y-axis, this is Y. What will be the structure? This is your X-axis. Suppose I want to explain about the dxy. Suppose I want to explain about the shape of dxy. A lobe is present in between this x-axis and y-axis. A lobe is present here also. That is your x-axis, y-axis. Here also, here also. Let me explain the other two. Look at that, the dx square minus y square. This is your x-axis, this is your y-axis, this is your z-axis. Let me explain. Sorry. This is your x-axis, this is your y, this is your z-axis. X square minus y square. This is one law present uh, aligned to the x-axis. That means lie along the coordinate axis. Here another lobe is present in the y-axis. Here another lobe is present. Also another lobe is present in the y-axis. Four lobes present in these two axes, x-axis, y-axis. They are lie along the coordinate axis, not in between the axis. So this is your said to be dx square y square orbital. Let me explain about the dz square. This is your x-axis, this is your y-axis, this is your z-axis. One lobe is present here, another lobe is present here. Then a ring is present like this, which is present in the xy plane, which is present in the xy plane. I am trying to show you. I am trying to show you. Look at the. Actually, this is not the proper. This is not circularly present. Let me explain. Okay. This is your suppose x-axis. This is your y-axis. This is your sorry. This is suppose this is your x-axis. This is your y-axis. This is your z-axis. Then present is like this. Look at that. Here one lobe is present. The second lobe is present here. Here a ring is present like this. Clear? I want to explain. In this ring, the probability of finding electron is maximum. But if you think about this space, look at this space. Here the probability of electron is 0. Clear? These are the five d orbitals. Remember this shape. Suppose a question will ask what is the shape of d orbital, then you can say that is your double dumbbell. Shape of d orbital is your what? Double dumbbell. In the previous class already I discussed shape of d orbital. Let me show the list. That is look at that. Here I have written double dumbbell shape. Shape of d orbital is your double dumbbell shape. Shape of f orbital is your triple dumbbell shape. This is the shape of d orbital. Next thing about the shape of p orbital. The f orbital are present in general in the n cell. The f subcell has 7 f orbital. F subcell have 7 f orbital. They are also identical energy but different in their orientation. All the orbitals having the same energy. Clear? Try to understand. Let me try to remember. How can you remember these orbital? Give the q of each: fxq, fyq, fzq. Remember these three. Next is another is the fxyz. You can easily remember. Take the three q of axis: xq, yq, zq. Another is our xyz. Then remember the circle. This is the circle. This is your x. This is your y. This is your z. Try to remember these orbitals. Write on first f. Write x. Then take the difference of the other two axes. Write down x. Then take that difference. Then take the difference of square of each axis. Let me write. First is your f. Then you can write x. This. Then y square minus z square. What will be the next? Write down fy. Give bracket. You can write z square minus x square. Next, what will be the another? Write down the z, f, z. Then give the bracket. You can write x square minus y square. These are the 7 f orbital. Remember a very important point. Since you are belongs to the plus 2 level, and the shape of f orbital is very complex. Think about the d orbital. Think about the d orbital. It is very difficult to understand. Since he belongs to the plus 2 level, intermediate level, so it is not necessary for to understood the shape of f orbital. Only remember there are there are 7 f orbitals are present belongs to the f subcell. Each orbitals having equal energy, but they have different orientation. And remember another important point: each orbital has 8 lobes. How many lobes? 8 lobes. It is very difficult to show the 4 lobes. Then it is also very complicated to show the 8 lobes. Again, I want to say that for your plus 2 level, this is not necessary to understand the shape of paper vital because it is very complicated. It is very difficult to draw in the 2D. That is your in paper. It is very easy it is very easy to understand in 3D. Thank you very much for this class. This is very sufficient. Thank you again very much for watching this video. Namaste.